people hear about distillation, sparsity, and maybe you can just tell us, like, with few words briefly, like what they mean in LLMs and also in quantization.
Yeah.
Sparsity.
So sparsity is like one additional technique to like reduce the size of models. And here we are reducing the size by actually eliminating the weights. In quantization, we are not removing any of the weights. We're just like reducing their bit width. Whereas in sparsity, we are completely like taking them out of the network.
Like, how do
So
they
you
choose
take
the weights? Like, which
so yeah,
weights to
that's
reduce? Like, you split it in
that's
two, like convert them into
so
zeros. Like,
that's
how do you choose the
yeah,
victim?
you convert them to zeros. That's the goal. So you want to convert them as many as possible to zeros. But then the entire game is like, how do you find which ones should go to zero? And there are like some algorithms for that, like a sparse GPT, which we've worked on, and so on, which are applying more or less the same tricks as we're doing in quantization. So you're trying to estimate the importance of specific weights in
So
a layer,
iMetrics
and
kind
then
of.
based on that, the entire iMetric story is very similar to like a GPTQ idea, where you're kind of, at least in GPTQ, you're just estimating like a hashing of a specific layer, but it's usually like in the end it ends up being like a huge like importance matrix, which tells you if you quantize or if you remove this specific weight, this is how you're going to affect all other weights in the network. And then based on that, you say, okay, I can quantize or I can remove this weight based on that. But it's more or less the same story, just kind of implemented in a slightly different framework. And for sparsity, it's the same. It's just like we're trying to set them to zero, and we see, okay, if we set these weights to zero, what's the effect on the accuracy of the model?
So it's not random.
Yeah, it's not random.
Okay, they're not shooting out weights.
Yeah,
and then like,
random
go to
is gonna
zero.
be really bad. Yeah, yeah, that's gonna be really bad. Yeah,
Nice.
and for GPUs specifically, the only choice we have is 2-4 sparsity, because that's what the NVIDIA offers us. Like they're like 2-4 sparse tensor cores, which means that for each block of 4 consecutive weights, you have to zero out 2 of them. So that's what the 2-4 means. And if you apply this format, then you can get like 2x faster forward pass on NVIDIA GPUs. And that's, for example, what we are usually doing.
Is it done at like kernel level? I'd say like at hardware level, at tensor level, or
yeah. So the sparsification process happens in the same way as the quantization process. You load one layer, you pass through some calibration data, you have this importance matrix, you figure out which ones to zero out, which ones to keep in the original form. And then once you save the model, you want to run it. And then that's the way. So like when you're running this on a GPU, there will be specific kernels which are going to be used explicitly, like for if it's like a 2-4 format, and they will, instead of using like BF16 tensor cores, they will go to sparse tensor cores, and sparse tensor cores have like more flops than the normal ones.
Right. So like the hardware will detect based on the kernel which one to apply sparsity on, or which one to zero.
So yeah, it will not apply sparsity. It will just leverage the fact that your model is already sparse. If you have the 2-4, it will literally just subselect the unsparsified weights. So you'll have like a 2x smaller matrix. It will do the matrix multiplication of that, and then it will like unwrap the results back to where they are supposed to be. So it will just detect that it's 2-4, and it's going to run on sparse tensor cores.
Nice. So it said, you call it 2-4? Is it named 2-4?
Yeah, it's 2-4.
Like the number?
Yeah, that's right. The general format is NM, like NM, but like the only thing we have right now is like 2-4. Yeah.
To like the numbers, or like to can you type it in the chat if you can, like just for
is it like 2:4?
2:4. Yeah, that's right.
Oh, okay. 2:4.
2:4, yeah.
Okay.
Which literally sounds like out of the 4 consecutive weights, 2 have to be 0. That's the format.
Okay, cool.
And there is also a way now to combine this with quantization. So you do 2-4 model, produce sparse model, then you quantize that model, and then you just compound the gains from both of these.
Wow! So that's 2 times faster plus, further fraction faster.
It's 2 times faster according to NVIDIA documentation, but in practice, it's not. It's not always that.
We'll wait for the customers.
Yeah.
We'll wait for the callback.
There's
just-
always some trade-off. It's not
of
always
course,
as
of
it
course.
looks
Expectation
in the
vs
official
reality.
docs.
Definitely,
Yeah.
man.